Assalamu alaikum dear students. We were solving exercise number 5.3 and question number 1 and 2 we have solved. In question number 1 it was just division of by using remainder theorem we have divide, and in question number 2 we have find the value of k by using factor theorem and remainder theorem. So students, today we have to solve question number 3 and 4, in which there will be a same concept, there will be a different methodology, same definition based, and different questions with different polynomials and their divisor. Now this question number 3, without actual division determine whether x minus 2 and x minus 3 are factor of p of x. Without actual division, it means not the division, actual division. We just need to determine that x minus 2 and x minus 3 are factor of p of x. And what is factor of p of x? In the last lesson I have explained you, if a specific linear equation is divided by that given polynomial and the answer, if the answer is 0, then that linear equation will be the factor of polynomial. It means we will put x minus 2 equals 0, x equal to 2 in this expression. If the answer is 0, we will say x minus 2 is factor of p of x. And similarly we will put x from x minus 3 by using remainder theorem. From x minus 3 equals 0, we will put x equal to 3 in that expression. If the answer is 0, then we will say x minus 3 is a factor of p of x. Otherwise we will write that x minus 3 is not a factor of p of x. So student, it has two parts. I will solve one of the part and second part you have to do yourself. I will go for second part, and first part you will do yourself, because in the second part we have x minus 2, x plus 3 and x minus 4, three factors. In this we will put these factors in q of x and check. If the answer 0, I will say that x minus 2 is a factor of this, and if the answer not 0, we will simply write it is not the factor of q of x. So I am going to write this question number 3. Without actual division determine whether second part I am solving x minus 2, x plus 3 and x minus 4 are factors of the polynomial. It is given q of x equal x cube plus 2x square minus 5x minus 6. We will check these three linear factor in the given polynomial, and if the answer is 0, we will say it is the factor of this polynomial. If the answer not 0, we will say that the linear factor is not the factor. Solution. Since x minus 2 divide q of x, divides the polynomial q of x, so using remainder theorem x minus 2 equals 0, we have x equal to put in q of x. Now in q of x, x is replaced by 2. q of 2 is equal x cube mean 2 cube plus 2 into x square matlab 2 square minus 5 x mean 2 minus 6. 2 cube is 2 multiplied by 2 4, 4 multiplied by 2 is 8, plus 2 into 2 square mean 2 multiplied by 2 4, and minus plus minus 5 2 time minus 10 minus 6. 8, 2 4s are 8, minus 10 minus 6. 8 plus 8 16, and minus 10 and minus 6 is minus 16. So 16 minus 16 equal to 0. As the answer is 0, so we will write So x minus 2 is the factor of q of x. It is simple. If the answer is 0, we will say it is a factor of this. I am going to again give you a reference. If 10 is divisible by 5, 5 2s are 10, its remainder is 0, we will say 5 is a factor of 10. In the polynomials it is same. Now we will check x plus 3. Since x plus 3 divide q of x, so using remainder theorem, x plus 3 equals 0, we have x equal minus 3, put in q of x, put the x equal minus 3 in that given polynomial. We have a q of minus 3 is equal to, x is replaced by minus 3 now, minus 3 cube plus 2 into minus 3 square minus 5 into minus 3 minus 6. Now cube of minus 3 minus plus 3 3s are 9. 9 multiplied by minus 3 plus minus, it is minus 27. Plus 2 into minus 2 square is 9. Minus plus 5 3 times, 15 minus 6. This is equal minus 27 to 9 times 18 plus 15 minus 6. Now we have 18 plus 15 positive, and minus 27 and minus 6 are negative. Adding them, 18 plus 15, 33, and minus 27 and minus 6 is also minus 33. So 33 minus 30 is equal to 0. So prove that x plus 3 is also the factor of q of x. Now at the end we will check x minus 4 is a factor of this polynomial. Students, they are very simple question. I hope you are enjoying this lesson today. Just simply we will put the linear equation in the polynomial, and at the end if the answer is 0, we will say it is factor, and if the answer is not 0, we will say that it is not the factor of that given polynomial. They are the simple question. There is no any difficulty in these questions. You can solve it simply. Just you need to divide the perfectly, and should mention that using remainder theorem from x plus 3 equals 0, x equal minus 3, and be very careful while solving them. Mostly students do the mistake here. They'll write minus 3 square as minus 9. No, I'm going to explain you another term. The negative, if a negative number have power odd 1 3 5 7 9 etc, it will also result minus 1. And if a negative number have even power 0 2 4 6 8, minus 0 power 0 is always 1. So if it has a even power, it will always result a positive number. So in this case, if the minus 3 has power 3, it means minus 3 has power odd number, so it will result minus 27. Some students write plus here. They not know the basic trick to multiply them. You can multiply them like this: minus 3 into minus 3 into minus 3, that is minus plus 9. So multiply by minus 3 plus minus 3 9s are minus 27. This is also another way in which you can multiply and no error appear in your multiplication. So I am now checking its last factor. I need to take the page. Now we'll check x minus 4. I need to come back and check. I'll be solving in the next page. we will write, since x minus 4 divide q of x, since x minus 4 divide q of x, I mean write q of x here again, that is x cube plus 2x square minus 5x minus 6, it is q of x. I had to turn the page, so I'm writing this polynomial here it again. Q of x is the given polynomial, and now we will check that x minus 4 divide q of x. Is x minus 4 is the factor of this by using remainder theorem. By using remainder theorem, x minus 4 equal to 0, we have x equal to 4. Q of 4 is equal to x cube minus 4 cube plus 2 into x square mean 4 square minus 5 into 4 minus 6. Now 4 cube, 4 multiplied by 4 is 16, 16 multiplied by 4 is 64, plus 2 into 4 square is 16, minus plus minus 4 5 times 20 and minus 6. 64 plus 32 minus 20 and minus 6 minus 26. 64 plus 32 is 96. 96 minus 26 is 66. We need to check this. 70, yes, it is 70. So this is not equal to 0. P as q of 4 not equal to 0. So x minus 4 is not the factor of q of x. Okay students, x minus 4 is not the factor of q of x, and if x minus 4 is the factor of q of x, then the remainder should be equal to 0. But here we have in the result is non-zero. The answer is 70, remainder is 70. So x minus 4 is not the factor of this polynomial. In our first and second part, where we divide the same polynomial by x minus 2, we get 0. And when we divide the same polynomial by x plus 3, we get the answer 0. So we say that x minus 2 and x plus 3 are the factor of q of x, but x minus 4, the answer, the remainder is 70. So conclusion of this question is x minus 2 and x plus 3 are factors of q of x, but x minus 4 is not factor. Q of x. Okay students, now I have solved the second part of this question. The first part is for you. You have books, and note down your homework now. In the homework, part number 1, without actual long division, determine whether x minus 2 and x minus 3 are factor of this. You will put x minus 2 in it, x minus 2 equal to 0, x equal to 2 is using remainder theorem, and check it in this question. If the answer is 0, you will say it is a factor of this polynomial, and then x minus 3, if the answer is 0, you will say it is the factor of p of x, otherwise not, and at the end you will conclude your result. So students, question number 3, 4, 5, 6, 7 and 8 and 9, they have a different kind, and they leave different remainder. We will start question number 4 inshallah tomorrow, where there are same concept, but in which we in all these questions we have to find some unknown, a, b, m, l or m something. So we will solve question number 4 tomorrow. I hope all of you understand the lesson. Inshallah we will start question number 4 and 5 in the next lesson. Thank you so much. Allah Hafiz.